All right, here we go. Unit 1, Day 6, Inverse Functions Algebraically. The goal for today is to be able to find the inverses of functions just from their equations without looking at a graph. So I'm going to be able to hand you a function like f of x is x squared plus 2. All right, that's a set of rules. Take a number, square it, and then add 2. You're going to be able to give me the set of rules that reverses that entire process, that takes the outputs from your first function and would turn them back into inputs, all without looking at a graph. But first, let's just remind ourselves of what we are talking about when we talk about inverse functions. Common notation is this f, what looks like to the negative first, but really means the inverse of f. It's a function that reverses the original function. It takes the outputs of f of x and turns them back into inputs. We started by looking at a graph because it's easy to think about what inputs and outputs are. Inputs are the x coordinates, outputs are the y coordinates. So to find the inverse of a function, in this case, we are given the function y equals x squared. All we have to do is find points on this function and swap their x, y values to find points on our new function. And so let's take a look at what this looks like. We've got our first point here, the vertex is at 0, 0. This one's not particularly interesting because if you swap 0 and 0, use a different color here, I'll use green. If you swap 0 and 0, you still have 0 and 0. So this is still going to also be a point on our new function, so I will put it there in green. We'll do one more uninteresting one, and then the rest will be interesting. Our last uninteresting one is 1, 1, because once again, when you flip that, when you flip the inputs and outputs, you still have 1, 1. So it's still nothing changing there. But when we look at some other points, say for example, x of -1, y of +1. Now, when we take the opposite, when we flip the x and the y, 1, -1, now we have a new point, 1 in x, -1 in y. That's probably enough to already maybe start to see what this function is going to look like, but let's be super sure. Let's take 2 more points. Let's look at the next ones over when x is 2, y is 4 on our original function. And so on our new function, that's going to be 4, 2, the other way around. 4, 2, there it is. And finally, the last one we should do -2, 4. And we're going to turn that into 4, -2. And so if we were to graph the inverse here of this relationship, if we were to graph the inverse, we can see that it's this same parabola-looking figure. It looks like it's been rotated 90 degrees. But exactly what's happened graphically is I want you to picture folding your paper on that blue dotted line. This is the line where all the x and y coordinates are the same. So this is the line y equals x. And to take an inverse, what that means is you're going to take from the top left-hand corner of your paper and you're going to fold it over to the bottom right, right over that blue dashed line. That is going to have the effect, if you reflect over the axis or reflect over the line y equals x, that's going to be finding your inverse. And so what we're going to do today, we're going to do that same process, but with our blinders on. We're going to do it without looking at the graph, and we're going to come up with what is the equation that describes this relationship given the original. And so let's look at what happens. We can also find inverses algebraically. The key point is kind of the similar one to the graph. To find the inverse of a function, we're going to swap the x and y values. And so if we have f of x equals x squared, first we're just going to replace f of x with y. We know that on a graph, f of x is our y coordinate. So we have y equals x squared. Step 1 done. Replace f of x with y. Step 2, I'm going to swap the x and y variables. I mean literally everywhere you see an x, replace it with the y. Everywhere you see a y, replace it with the x. So instead of y equals x squared, we have x equals y squared. To find the inverse, we now need to solve for y. Right? Our goal is to always get down to that y equals. In this case, this is going to be the inverse of our function once we've done this. And so we're going to solve for x. We're going to do that using inverse operations. We're going to solve for y. We're going to solve for y using inverse operations. Right now we have y squared. The way we undo squaring a number is to take the square root. That's the inverse operation of squaring. So our final answer here, we would have the square root of x equals y, or y equals the square root of x, or final answer, the inverse of y equals x squared is the square root of x. I'm going to show you a few examples here and then send you on your own to practice some of these on Delta Math. We're going to start with just a reminder of our classic inverse operations, right? Inverse operations are, in Algebra 1, how we learn to solve equations. We're going to say we want to solve all these for y. So the first pair, addition and subtraction, those are inverse operations. If I want to remove that minus 3, I need to subtract 3 from both sides of the equation. When I say both sides, I mean both sides of the equal sign. So we have x minus 3 equals y. On the other side, if we want to undo subtracting 5, we would add 5 to both sides. So we would wind up with x plus 5 equals y. Notice I'm not combining the x and the 5. They're not like terms. One's a variable, one's a number. Next pair, multiplication and division. To undo 3y, which means 3 times y, we do division. If you multiply by 3, then divide by 3, you are back where you started. So we divide both sides of the equation by 3. That leaves us with x over 3 equals, when the 3's become 1, x over 3 equals y. Likewise, we could do division. This is y divided by 7. To undo that, we're going to multiply both sides by 7. That leaves us with 7x equals, 7 divided by 7 is 1, just a single y. There's your final answer. The last two, you do want to know that the opposite of squaring something, multiplying it by itself, is to take the square root. So if we have x equals y squared, we're going to take the square root of both sides. Just to give you an example, let's say y was 4. If y was 4, 4 squared would be 16, and the square root of 16 would be 4. We'd be back where we started. That's why these, the squared and the square root, they undo each other. They are inverse operations. We have the square root of x equals 4. Likewise, if you already have the square root of y, you would undo that by squaring both sides of this equation. So we'd have x squared is equal to y. Now this same process will apply for all other kinds of roots. The square root is the basic one. It doesn't get the small number that we call the root number. It's just understood to be 2. The next one up would be a cube root. And so the way we could undo y to the third would be to take the cube root. We put that little number 3 in there. Those are inverse operations. One's saying do a number times itself 3 times. The other is saying what number times itself 3 times would give me that. So like if y was 2, 2 cubed, 2 times 2 is 4, times another 2 is 8, and the cube root of 8 is 2. So that's how you would get back to regular old y. The cube root of x equals y. Same thing here, to undo a cube root, you'd raise both to the power of 3. So we'd have here x cubed equals y. Okay? We're going to finish off today by just doing a couple of these examples in full, finding inverses. I want you to remember some key equation solving principles. If you ask me for help today, I'm probably going to direct you to one of these two things. One, you can do anything to an equation as long as you do it to both sides. 2, if you're going to multiply, divide, or raise to a power, you have to do it to the entire side. So what I recommend to do to make sure you do that is if you're going to multiply, divide, or raise to a power, always put a parenthesis around the entire equation. Finally, if you raise one exponent to another one, the 2 multiply, and we'll see how that might be useful. Let's look at 4 quick examples. First, find the inverse of 2x plus 3. Well, step 1 was to just replace f of x with y equals 2x plus 3, just to make my notation easier. Step 2 is to replace our x and y values. So we'd have x equals 2y plus 3. And now I just need to solve for y. That's step 3. So step 3, I need to get the y by itself. I can't get rid of the 2 yet, and I want you to see why. I'd have to divide the entire side by 2, which means the 3 gets divided by 2. It would get ugly. It's way easier to first subtract 3 from both sides. That leaves us with x minus 3 equals 2y. And now we can divide by 2. Divide the entire side by 2. Divide the entire side by 2. This leaves us with a final answer of y equals x minus 3 over 2. The inverse of x equals x minus 3 over 2. Step 1, replace the f of x with y. Step 2, swap your x and y variables. Step 3, solve for y. That is how you find the inverse of a function. I'm going to up the difficulty just a couple times. If we have, got to stop eating chips before I make these videos. If we want to find the inverse of x plus 2 over 3 minus 7, same thing. First, we're just going to, I'll do the same colors to stay consistent here. First, we'll just say y equals x plus 2 over 3 minus 7. That's step 1. Step 2, I'm going to go ahead and swap the x and y values. So x equals y plus 2 over 3 minus 7. Step 3 is to start solving. So the first thing I would do, I would move this minus 7 over. I would add 7 to both sides. That leaves us with x plus 7 equals y plus 2 over 3. My next step here, I'm going to multiply both sides by 3. I have to do it to the entire side. So I would have 3 times x plus 7 equals y plus 2. And now it's your choice. You can subtract 2 on both sides and be done here, but let's make it a little bit simpler. The reason we're going to do this, we're going to distribute into here and have 3x plus 21 equals y plus 2. This is not strictly necessary, but I like to do it here because it makes my final a little bit simpler, because now I can subtract 2 from both sides to get 3x plus 19 equals y. The inverse of that one is going to be 3x plus 19. All right, 2 more to go here. You got this. Find the inverse of f of x, going to replace that with y, equals x minus 6 squared minus 4. Then we're going to step 2, swap the x and the y. X equals y minus 6 squared minus 4. This is going to be when we add, now we go to step 3. We add 4 to both sides, plus 4 over here, plus 4 over here. That's going to leave us with x plus 4 equals y minus 6 squared. If, as you need to now, you need to take a square root, you do it to the entire side of an equation. So what we're left with here is the square root of x plus 4 equals y minus 6. When the square root and the squared cancel out, final answer, y equals the square root of x plus 4. Then, after we have finished this off by adding 6 to both sides, one's inside the square root and one's outside. We can't combine those. This is going to be y equals the square root of x plus 4 plus 6. There is our last inverse, or second to last inverse function. And the last one for today. You want to be able to refer back to all of these. It's okay if it's not completely making sense yet. You'll get practice on the delta math. Reach out when you need help. This is just, go through this, let it sink in a first time so you know where to look if you need help. Last one here, if we have number 1, first I'm going to swap f of x, y equals 3 times the square root of x plus 2. Step 2. I'm going to go ahead and swap the x and the y values. X equals 3 times the square root of y plus 2. I can't square both sides yet, or I don't really want to. So the first thing I'm going to do is divide by 3. to get that square root by itself. So we'd have x divided by 3 equals the square root of y plus 2. Now I have that square root alone. I'm going to square both sides. This is going to get a little bit tricky here, but what we're going to have is x over 3 squared equals y plus 2. X over 3 squared, remember, means x over 3 times x over 3. So we're going to have x squared over 9 when we multiply straight across. Multiply fractions, you just multiply straight across the top, straight across the bottom. We're going to have x squared plus 9 equals y plus 2, which means that our final answer here, when we subtract 2 from both sides, we'll have y equals x squared over 9 minus 2. The inverse is equal to x squared over 9 minus 2. Final answer there.